In this module, let us discuss vectors in R4 and more than dimension 4. In R4, we are already discussed in R2, that is in plane, and in space, that is in R3. In this module, let us discuss in 4 dimension, 5 dimension, etc. in n dimension. So in this module, let us take x equal to, say, x1, x2, x3, x4 is a vector in R4 such that this x can be expressed as x1 into 1 0 0 0, that is x1 e1 plus x2 e2 plus x3 e3 plus x4 e4, where e1 is the vector, say, 1 0 0 0 and e2 is 0 1 0 0, etc. So generally, if x is a vector in Rn, then this x can be expressed as x equal to x1 e1 plus x2 e2 plus etc. plus xn en, where what about en? En is the vector with all the entries 0 except for the ith position. Then let us discuss, just similar to this R2 and R3, let us discuss all the properties of these vectors. So first of all, we can define the equation of a line, say, and is parallel to you. We know if x is line parallel to you, then x equal to t into u, or x is minus t into u, or the equation is x plus tu equal to 0 is a line which is parallel to you. Then we can find some equations. Then let us consider an example. Find the equation to a line parallel to, say, 1 parallel to 1 1 1 2. That is capital X, that is x1, x2, x3, x4 equal to plus t into 1 1 2 equal to 0. That is x1 plus t equal to 0, x2 plus t equal to 0, x3 plus t equal to 0 and x4 plus t equal to 0. Then let us discuss centroid. What is a centroid? We can define if x1 is a vector, x2 is another vector, etc. X are vectors, then its centroid denoted by x bar equal to x1 plus x2 plus etc. plus xr by r. Okay. Let us consider an example. Find the centroid of, let us consider the centroid of e1, e2, e3, e4. Then we know, then e1 equal to 1 0 0 0 plus e2 equal to 0 1 0 0 plus 0 0 1 0 plus 0 0 0 1 divided by, there are 4 vectors, by 4. That is 1 1 1 1 etc. by 4. Therefore, centroid equal to 1 by 4 1 by 4 1 by 4 1 by 4. That is the centroid of this e1, e2, e3, e4. Then let us discuss the dot product of these vectors. Just similar to this 3 dimension, we know if x equal to, say, x1, x2, equal to x1 u1 plus x2 u2 plus x3 u3 plus x4 u4 by x3 u4 is the dot product. Then we can find the angle between these two. We know if x and u are the two vectors, then if theta is the angle between x and u, then cos theta, the angle between this is defined as x dot u by modulus of x into modulus of u. Then we define hyperplane. Hyperplane is a set of vectors which is orthogonal to the given vector. Yes. So, find the hyperplane is orthogonal to, say, find the hyperplane which is orthogonal to, find the hyperplane which is orthogonal to E1 plus E2, comma, minus E3, comma, E4. Yes. E1 plus E2, E1 plus E2 minus E3 plus minus E4. Find the hyperplane. We know this vector E1 is nothing but E1 equal to 1, 0, 0, 0 plus E2. E2 equal to 0, 1, 0, 0 and minus E3 equal to 0, minus E3 equal to 0, 0, minus of 0 and minus E4 equal to 0, 0, 0, minus. Therefore, E1 plus E2 minus E3 minus E4 is nothing but that is equal to 1, 1 minus 1 minus. Therefore, we can find so many vectors which are orthogonal to this. So, first vector is 0, 0, 0. So, x equal to 0, 0, 0, 0. We can see that x dot this vector, say v or u. What is x dot u? 0 into 1 plus 0 into 1 plus 0 into minus 1, etc. Therefore, this vector x is orthogonal to u. Similarly, we can find another vector, say x equal to, say, 1, 1, 1, 1. What is the dot product? 1 into 1 plus 1 into 1 plus 1 into minus 1 plus 1 into minus 1 equal to 0. Therefore, this vector, say, 1, 1, 1 is also orthogonal to this u. Similarly, we can find another vector is 1, 1, 1 is 1, 1, 1. X equal to 1, 1, yes, 1, 0, 1, 0. Then we can see 1 into 1 plus 0 into 1 plus 1 into minus 1 plus 0 into minus 1. It is also 0. So many vectors are perpendicular to, orthogonal to u equal to E1 plus E2 minus E3 minus E4. Then we know we have defined another vector, another property, that is orthonormal set. What is an orthonormal? A set of vectors are said to be orthonormal if their modulus of that vector x equal to root of x1 square plus x2 square plus x3 square plus x4 square for R. Therefore, a set of vectors are said to be orthonormal if their modulus is 0, 1, unity, and they are pairwise orthogonal. That means their dot product equal to, the angle between these two is 90 degree, that is dot product equal to 0. So we can say, we can discuss what are the orthonormal sets. Consider the set, say, cos theta E1 plus sin theta E4, one of the vector. Then E2, we can see E3, and we can collect another vector minus sin theta E1 plus cos theta E4. You can see that this collection of vectors is a collection of vectors in R4. They form orthonormal set. First of all, we have to verify their modulus is unity. What is the modulus of this? Cos theta E1 plus sin theta E4. This cos theta into 1, 0, 0, 0 plus sin theta into 0, 0, 0, 1 equal to cos theta comma 0, second coordinate is 0, third coordinate is 0, and fourth coordinate is sin theta. Therefore, modulus of this vector, say this may be u1. Modulus of u1 equal to root of cos square theta plus 0 plus sin square theta, that is root of cos square theta plus sin square theta equal to 1. Therefore, this first vector u1 is having modulus unity. E2, we always know it is modulus is unity, and E3 is modulus is unity. Then we have to check whether for U4 is nothing but U4 equal to minus sin theta E1 plus cos theta E4. That is equal to minus sin theta, just as the previous case, 0, 0 and cos theta. So again we can see that modulus of that is minus sin theta, the whole square is sin square theta plus cos square theta. So it is also unit. Therefore, these four vectors, the set of vectors, say capital V dash V, considering four vectors, they have modulus unity. Again, we have to check whether they are pairwise orthogonal. For this vector, say u1 equal to we know cos theta, comma 0, 0 sin theta. Dot E2. E2 is 0, 1, 0, 0. What is the dot product? Cos theta into 0 plus 0 plus 0 plus 0 equal to 0. Therefore, U1 and U2, it is U2, is orthogonal. Similar, the angle between these two is 90 degree. Similarly, we can see that U1 and U3 is also 0. Also, we have to check whether U1 and U4. U4 is nothing but it is dot minus sin theta 0, 0 cos theta. What is the dot product? Minus sin theta cos theta plus 0 plus 0 plus sin theta cos theta. It is also 0. Therefore, this set V form an orthonormal set. Okay. Orthonormal set is the set of vectors which are pairwise orthogonal and their modulus is unity. Then, we can find the angle between the two vectors. What is the angle between the two vectors? Angle between the two vectors is cos theta equal to x dot u by modulus of x into modulus of u. So, if one of the vectors, say u equal to E1 plus E2 and another vector v equal to, say, E1 plus E2 plus E3 plus E4, then what is u dot, what is E1 plus E2? So that is u equal to 1, you know, this is E1 1 0 0 0 plus 0 1 1 0 and v equal to 1 1 1 1. Therefore, cos theta equal to x dot u dot v, that is 1 into 1, 1 plus 1 plus 0, 0 divided by this modulus of 1 plus 1, that is root of 2 plus root of 4, that is 2. That is 2 by 2 root 2, that is 1 by root 2, that is 45 degree. Theta equal to 45. So we can find the angle between the two vectors. Then, just as the plane and space, we can define these transformations. First transformations, we all know the projection Px. Projection Px is nothing but it is x dot u into the vector u by modulus of u square. Then we define this reflection, it is projection on x along u. Then Sx equal to 2 into Px, we have already seen, minus x. Similarly, Qx is the projection along a line which is perpendicular on a plane, which is that plane is passing through the origin and perpendicular to the vector u is Qx. Qx is nothing but it is x minus p, that is x minus px. Yesterday we have seen that in the second module. Again we can see the reflection, projection, then rotation. So we can easily find one of the example. We can see that we find the projection of x along u equal to say 1, 1, 1. Then what is p of x equal to x dot u. X dot u is x equal to x1, x2, x3, x4. Therefore, x dot u equal to x1 into 1 plus x2 into 1 plus x3 into 1 plus x4 into 1 by modulus of u square. Modulus of u is 1 plus 1 plus 1, that is 1 square plus etc. 4, that is 4 root of 4, that is 4, modulus of u square is 4 root 4 the whole square into 1 u is 1, 1, 1. Therefore what is px? Px equal to first coordinate is x1 plus x2 plus x3 plus x4 by 4. Just for the 3 dimension it is by 3. 4 dimension it is 4. Similarly, how many coordinates we have? 4 coordinates. x1 plus x2 plus x3 plus x4 by 4. x1 plus x2 plus x3 plus x4 by 4. And the last one is x1 plus x2 plus x3 plus x4 by 4. It is the vector. Similarly, we can find the projection. It is the projection and the reflection. So it is can be represented as, the projection can be expressed as x1 by 4, x2 by 4, x3 by 4, x4 by 4, etc. So just previous case we can represent them as matrices. Matrices is nothing but matrix of P. Projection is nothing but 1 by 4, 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 1 by 4. Then that is matrix of P. We know the reflection. Reflection is M of P minus I, or this Sx equal to P of x minus x. Therefore, matrix of P minus I of x. MP minus I. matrix of P minus I. Therefore, matrix of S equal to matrix of S equal to matrix of S equal to MP minus I equal to 1 by 4, 1 by 4, 1 by 4, 1 by 4, etc. Minus I. I is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 1. That is the matrix of S equal to matrix of S equal to 1 by 4 minus 1, that is minus 3 by 4, and all the remaining elements have no change. Similarly here 1 by 4, the diagonal elements are minus 3 by 4. Thus we can find matrix linear and transformation. Then let us discuss rotation. Yes. So we know projection, reflection on a line, and also we discuss the projection QX on a plane, that is QX. QX we know it is X minus PX. So correspondingly we can find that matrices. Then we have the rotation. This is another transformation. That is, we defined here two 1, 2 of theta. That is the first and second axis. That is x1 coordinate and x2 coordinates are changed to an angle theta, and the third and fourth remains constant. So R1, 2 of theta, we know. In the first and the second module we know this, if it is first and second coordinate, this plane is rotated through an angle theta. It is x1 cos theta minus x2 sin theta. Then x1 sin theta plus x2 cos theta, and the remaining change no change, x3, x4. That is the rotation of the x1 and x2 through an angle theta. If we have taken two rotations, suppose R12 and R34 for an angle phi, we have this also changed. Okay. So find, for example, find an example, that is R phi. Find R phi 1. R phi 1 2 means we change this angle through an angle, this axis through an angle phi. So x1 cos phi, sin phi, here sin phi. So this becomes x1 into cos phi is cos 180, that is minus 1. Cos pi equal to minus 1. So it is minus x1. Sin pi is 0. Similarly here, x1 into sin pi is 0, but x2 into cos pi is minus x2. Then x3 and x4 no change. Therefore, it is R phi of 1. Then we define a linear transformation. This is a very interesting thing. That is a linear transformation defined from a 4-dimension to 2-dimension. That is a linear transformation T, which is defined from R4 to R2 such that T of, how we define? T of x1, x2, x3, x4 is, we assume that this x3 and x4 are 0, so we can see that it is equal to x1, x2. This is a linear transformation. But if we consider a transformation, that transformation T to R3, R theta of 1 to what happened? This x3 and x4 becomes 0, so we get only this T of, if we are asked to find T of R pi of 1 2 equal to only minus x1 minus x2. Similarly, we can see that if u equal to, if there is an example, so we have defined rotation and also the linear transformation from 4 dimension to 2 dimension. Then take an example. This is an important example. Show that the vectors V1 equal to show that the transformation T from R4 to R2 from U equal to where U equal to 1 1 0, V equal to 0 1 0 0 and W equal to 0 1 1 1, determine an equilateral triangle. What happened here? T of U equal to, we know T of U, R4 to R2. What happened? The last two coordinates become 0, so it is 1 1. Similarly, what is T of V? T of V is 0 1 and T of W equal to 0. Here it is 1 0 1. Yes, 1 0 1 1. So T of W equal to 1 0. Therefore, we can map this into a figure. First is T of U. T of U is here 1 1. It is T of U. The point 1 1. Okay. Similarly, T of V is 0 1. That is 0 1. T of V equal to 0 1. And also T of W is 1 0. T of W equal to 1 0. So if we join these 3 points, yes, it is T of U, it is T of V and T of W. We can get an equilateral triangle of length 1. Therefore, this transformation T from R4 to R2 transfer these vectors U, V, W to an equilateral triangle. Then consider a 4 cube. 4 cube, we can see that there are so many points 1 1 1 of the point. Then 1 1 0 1. That 1 1 minus 4 cube 1. Then 1 1 minus 1 minus 1. We see that T of this is also equal to T of this equal to the first coordinates is 1 1. Here also its transformation is also 1 1. Its transformation is also 1 1. So similarly we can see that it is also. So there are 4 points 1 1 1, 1 1 minus 1 1, 1 1 minus 1 minus 1 and 1 1 1 minus 1. These 4 points maps to 1 1. Similarly we can see minus 1 minus 1 0 0, sorry 1 1 etc. 4 points maps to minus 1 minus 1. Thus there are this 4 cube has 16 points, but its image has only 4 points, 4 vertices. Yes. Then we can find the rotation of this transformation by means of this rotation and this transformation. Find T R theta of 1 2 R theta 30 of 3 4. What happened? So we can see that of the vector, say vector is say so we have to first rotate this 1 1 through an angle theta. So T R 1 to 30 of R 30. We know the here first is 3, 4. 3, 4 is the third and fourth coordinates. So 1, 1 remains changed. We have to find 1 cos 30 minus 1 sin 30. Similarly, 1 sin 30 plus 1 cos 30. It is equal to T r 1 to 30 of 1 cos 30 is 1 by 2 minus root 3 by 2. Root 3 by 2 minus 1 by 2. Here sin 30 theta equal to 30, so it is sin 30 is 1 by 2 minus plus root 3 by 2. Then we have to find T of R30. Again we are 1 2 here also 1 into same as root 3 by 2 minus 1 by 2, 1 by 2 plus root 3 by 2, again these two, root 3 by 2 minus 1 by 2, root 1 by 2 plus root 3. Again we have to apply R4 to R2. So these two become 0. So the final image is root 3 by 2 minus 1 by 2, 1 by 2 plus root 3. Okay. So we have rotation, reflection, linear transformation, etc. Then we have seen the matrices. Again, what is a matrix transformation of? Yes, M of R theta of 1, 2. What is the matrix of this R theta of 1, 2? We know this R theta of 1, 2 equal to x1 or along this one, the vector 1, 1, it is, yes, first of all we can see that it is x1 cos theta minus x2 sin theta, then x1 sin theta plus x2 cos theta, then x3 x4. If this of suppose that vector is 1, 1, 1, we have it of 1, 1, 1. So x1 equal to 1, x2 equal to 1, x3 equal to 1, etc. We get, otherwise we can see that, or simply that is x1 into cos theta minus x2 into sin theta plus x3 into 0, x4 into 0. So that matrix of that is matrix equal to, so that matrix equal to coefficient, that is cos theta minus sin theta 0, 0, then sin theta cos theta 0, 0, 0, 0, 1, 0, 0, 0, 0. That is the matrix representation of a rotation along one on the axis x1 and x2 through an angle theta is the matrix. Cos theta minus sin theta cos theta 0, 0, 1, 0, etc. It is very simple. Yes. Similarly, we can find any other transformations and matrices. Okay. Then we are come on to system of equation and system homogeneous equations. First of all, we can find homogeneous equation. What is a homogeneous equation? An equation of the form a11 x1 plus a12 x2 plus etc. plus a1n xn equal to 0. a21 x1 plus etc. plus a2n xn equal to 0. Such type of equations are called homogeneous equation. A system of homogeneous equation means in n unknowns. We have seen for every equation, say in the second module, or we have seen that if 2x plus 3y plus 5z equal to 0, this equation has a trivial solution, that is x equal to y equal to z equal to 0. It is a trivial solution. If it has solutions other than trivial solution or non-trivial solution, we have to check. For that, find the solution, how we can express. Find the solution of x1 plus 2x2 plus 3x3 minus x4 equal to 0, and also x2 plus x3 plus x4 equal to 0. It is a system of homogeneous equations in 4 unknowns, but it has only two equations. So we can find complete solution. First solution, we all know x1 equal to x2 equal to x3 equal to x4 equal to 0 is the trivial solution. Then we have to find non-trivial solution. For that, consider we can multiply this equation by 2. It is 1, 2. Then 2 into 2. We get 2x2 plus 2x3 plus 2x4 equal to 0. Therefore, adding we get x1, subtracting we get x1 minus x3 minus 3x4 equal to 0. x1, yes, x1 minus x3 minus 3x4 equal to 0. Or x1 minus x3 equal to 3x4. Yes. And we can take any arbitrary value for this, say x1, then we can take x1 equal to an arbitrary value. Whenever you like, put x1 equal to, say, u, x3 equal to u, and x4 equal to v. What happens? If we take an arbitrary value 1 or 2, etc., generally say x3 equal to u and x4 equal to v, we can, since there are two equations in 4 unknowns, so we can arbitrarily take two values, arbitrary values. So we have x3 equal to u, x4 equal to v, and what about x2? x2 equal to x1 equal to x3 plus 3x4. That is x1 equal to x3 is u plus 3v. And what about so we find x1, x3, x4. Then the remaining stages we have to find x2. What is x2? We have given that x2 plus x3 plus x4 equal to 0. Therefore, we get x2 equal to minus x3 minus x4. x2 equal to minus x3 minus x4 equal to minus u minus. Thus we have x1 equal to, what is x1? u plus 3v. x2 equal to minus u minus v. x3 equal to v. x3 equal to u and x4 equal to v. So what is the complete solution? The solution is x equal to x1, x2, x3, x4. That is equal to u plus 3v, x2 minus u minus v, u v. That is can be expressed as u into, here the coefficient is 1, here the coefficient is minus 1, 1, 0, plus v into, here coefficient is 3, minus 1, 0, 1. It is the complete solution of the system of non-homogeneous equation. For any value, say for giving u equal to 1 and v equal to 1, we have a solution, non-trivial solution. It is not equal to 0. So, for any system of equation, we can have either trivial solution only or non-trivial solution. Then, another method is Gaussian elimination method. It is the one of the easiest method by putting the values, arbitrary values. If there are two equations in 4 unknowns, we can find arbitrary value for 2. If there are 5 unknowns in 2 equations, then we can give arbitrary values for 3 values. Okay. So, another method is Gaussian elimination method. Solve the following by Gaussian elimination method for the problem. Say x1 minus 2x2 plus 3x3 Gaussian elimination method. So we can eliminate. My x1 minus 2x2 plus 3x3 equal to 0. Then second equation is x1 plus x2 plus x4 equal to 0. And 4x3 minus x4 equal to 0. So here we can eliminate. First of all, what is from the third equation we know 4x3 equal to x4 or x3 equal to 1 by 4 into x4. 1 by 4 into x4. Then here yes, x1 plus x2 equal to minus x4. And from these two equations, we can eliminate. That is x1 minus 2x2 plus 3x3 equal to 0. And here we can eliminate one of the variables, x1 plus x2 plus x4 equal to 0. So we can subtract. We get minus x2 plus 3x3 plus x4 plus 3x3 plus x4 equal to 0. Therefore, what is x2? x2 equal to 3x3 plus x4. 3x3 plus x4. x3 plus x4 equal to 3x3 plus x4 equal to 3 into what is x3? x3 is 1 by 4 x4 plus x4 equal to x2 equal to here the equation is x1 plus x2 equal to 0. We have x1 plus x2 plus x4 equal to 0. We have x2 plus x4 equal to 0. And also x1 minus 2x2 plus 3x3 equal to 0 gives minus 3x2. Yes. So minus 3x2 equal to 3 plus 4 minus 3x2 plus x4 equal to 0 minus 3x2 So minus 3x2 plus 3x3. Yes. Minus x4. Subtract. Minus 3x2 plus 3x3 minus x4 equal to 0 gives minus 3x2. Yes. Minus 3x2 equal to 3x3 minus 3x2 equal to 3x2 minus 1 by 4 into x2. That is equal to 3 into x3 is 1 by 4 x4 minus 1 by 4 x4. On solving we get it is equal to minus 1 by 12 x4. Thus we get x3, x2, and we can see that x1 equal to 1 by 12 x4, 1 by 12 x4 minus x4 equal to minus 11 by 12 x4. Yes, minus 11 by 12 x4. Thus we have capital X equal to x1, x2, x3, x4 equal to first is x1. x1 is minus 11 by 12. Minus 11 by 12 x4. And x2 is minus 1 by 12 x4. And x3 is minus x3 equal to 1 by 4 x4 and this 1 into x4. Thus we eliminate all the variables in terms of x4. It is the Gaussian method. Then we have another example. Find the vectors which is perpendicular. Find the vector which is find a non-zero vector x1, x2, x3 in R3 which is orthogonal to 2, 3, 0 and 1, 1, 1. So, since this vector is orthogonal to this vector, we have the first equation is 2x1 plus 3x2 equal to 0. Second is x1 plus x2 plus x3 equal to 0. So, we have two equations in two homogeneous equations in three unknowns. Thus, we can solve this by elimination method. Here, x3 equal to then here 2x1 equal to minus 3x2. That is x1 equal to minus 3 by 2 into x2. Therefore, here x1 minus 3 by 2 x2 plus x2 plus x3 equal to 0. Therefore, what is x3? x3 equal to 3 by 2 minus 1 into x2 equal to 1 by 2 into x2. Therefore, x equal to x1 is minus 3 by 2, x2 equal to x2, then x3 is 1 by 2 into x2. So, if we multiply throughout by, so for any value of x2 equal to, suppose x2 equal to 1, we have the solution is minus 3 by 2, 1 by 2, or minus 3, we can multiply by 2, we get that x equal to say minus 2, 2, 1. We can see that this vector minus 2, 2, 1 is perpendicular to this vector 1, 1, 1, etc. Then we are come on to inhomogeneous equation. Inhomogeneous equation. equation means a11 x1 plus etc. plus a1n xn equal to say u1, not 0. a21 x1 plus etc. plus a2n xn equal to u2 etc. So, this system is called an inhomogeneous equation. For example, we can solve this inhomogeneous equation. One of the inhomogeneous equation may be say 2x plus 3y equal to say 3y plus z equal to say 5 and x minus y minus z equal to 10. It's an inhomogeneous equation. So we have, first of all, we can eliminate these variables. We know from this first equation, multiply this by 2, we get 2x minus 2y minus 2z equal to 2. Then subtracting, we get 5y plus 3z equal to minus 15. Yes. So what is that is 5y equal to minus 15 minus 3z. Therefore, y equal to minus 3 by 5 into z. So, we express y in terms of z. Then we can express x. What is x? We know we are given that. The first condition is x minus y, but 5y plus, we are given that, we know 5y plus this. Then we have x equal to first equation is x minus y minus z equal to 10. Therefore, what is x? X equal to 10 plus y plus z. That is 10 plus y. Y is minus 3 by 5 z plus z. That is 7 minus 2 by 5. So we express this as x, y, z equal to x is 7 minus 2 by 5 into z. Then y equal to minus 3 minus 5, 3 by 5 into z and z. Put z equal to t. Then we get 7 minus 3, 1, 0 plus t into, put z equal to t. Then 2 by 5, minus 2 by 5, minus 3 by 5 and 1. For any value, arbitrary value of t, we can find the system of inhomogeneous equation. Then we can discuss some more parts in module 2. In module 2, we know t of x equal to u. It has a unique solution. First is dx equal to u has a unique solution if t is invertible. That is, if t has an inverse. If t has an inverse. If t has an inverse, we can say that t inverse tx equal to x. X equal to u is unique. If t fails to have an inverse, we have no unique solution. We can have so many solutions in terms of t by putting t 1, 2, etc. Similarly, we can see that tx equal to 0 has only trivial solution when t has an inverse. If t has an inverse, t inverse tx equal to 0 only. That is, x equal to 0 is the solution. That solution is trivial solution. So a system of equation Tx equal to 0 has your trivial solution only if it has a inverse. If it fails to have an inverse, it has more than one solution. And also we can find the solution. If x bar is a particular solution, then we can see that x bar is a particular solution of Ax equal to u, and x is a non-zero solution. Non-zero, it is a non-trivial solution. Non-zero solution. Then this Ax equal to u has a solution, nothing but say if Ax equal to u has a solution, a particular solution x bar, and x is the non-zero solution, then Ax has the solution x bar plus x into x. Once again, if Ax equal to u with A fails to have an inverse. If A has an inverse, it is unique solution. If that fails to have an inverse, we can find a solution. What is that solution? X bar plus xh, where x bar is the particular solution of Ax bar equal to u, and xh is the non-trivial solution of Ax equal to 0. Okay. Once again, if Ax equal to u with A fails to have an inverse, then this Ax equal to u has a solution. It is nothing but x bar plus xh, where x bar is the particular solution of Ax equal to u, and xh is the non-zero solution of Ax equal to 0. It is very important. So we can say find all solutions of the system of equation. Say x1 plus x2 plus x3 equal to 1. 2x1 minus x2 equal to say 5. 5x1 plus 2x2 plus 3x3 equal to 8. We can see that it fails to have an inverse. Therefore, first of all, we can find the solution of this xh. That is non-zero solution of this homogeneous equation. It is an inhomogeneous equation. We can convert it into homogeneous equation. x1 plus x2 plus x3 equal to 0. 2x1 minus x2 equal to 0, and 5x1 plus 2x2 plus 3x3 equal to 0. We can see that the solution is very simple. That is x2 2x1 equal to x2 gives x2 equal to minus x1 equal to 1 by 2, and substituting that value we get x3 also. So we get x1 x2, x3 or xh equal to x of h equal to, we can see that 1 into x1, then x2 equal to minus 2, and x3 we can solve, that is it is equal to x2 equal to 2, yes, x2 equal to 2, 2x1, and x3 equal to minus 3. Therefore it is the non-trivial solution of Ax equal to 0. Then we can find another solution, x bar, particular solution of this equation. This equation gives by putting values for just as the previous case. We can see that x1 plus x2, put x3 equal to 0. We can take particular value for x3 equal to 0. We get x1 plus x2 equal to 1. And 5x1 plus 2x2. 5x1 plus 2x2 equal to 8. Multiplying this by 2x1 plus 2x2 equal to 2. And solving we get to 3x1 equal to 6. That is x1 equal to 3. And x2 equal to x1 equal to 3. Then we take this value in this equation. We get 5x1 minus 3x1 equal to 6. Yes, x1 equal to 2. x1 equal to 2. Then x1 plus x2 equal to x1 plus x2 equal to 1. Therefore, x1 plus x2 equal to 1. 2 plus x2 equal to 1 gives x2 equal to minus 1. So, this arbitrary solution is x1 equal to 2, x2 equal to minus 1, x3 equal to 0. Therefore, the whole solution is x bar plus xh. Okay. Then we come on to determinant. We know determinant is for a matrix is 2 by 2 matrix. We know every square matrix have a determinant, say A, B, C, D. Then determinant of this matrix is defined as AD minus BC. Is denoted by A, B, C, D. Then similarly for 3 dimensions, let A equal to, for 3 dimensions, let A equal to A1, A2, A3, B1, B2, B3 and C1, C2, C3. Then determinant of A is defined as A dot B cross C, or it is the same as B dot C cross A, or it is the same as C dot A cross B. This is the determinant. And it is the value obtained by this B. B is B1, A is the vector A1, A2, etc. So we can see that it is equal to nothing but yesterday we have seen that A dot B cross C is A dot B cross C. A dot B cross C equal to A1 into B cross C is B1, B2 C3 minus B3 C2 first coordinate plus minus A2 into second coordinate is B3 C2 minus C1 B3 C1 minus B3 C1 minus C1 B3 plus A3 into B1 C2 minus C2. It is the determinant. Okay. Then the determinant has so many properties, that is, if we interchange the two values, this 2, we can see that it is minus of that value. So A dot B cross C equal to this, we can take interchange. Therefore, it is minus of that. Then we defined eigenvalues. Eigenvalue, just for the plane, we can see that if a scalar t element of R is said to have an eigenvalue, if there existed in a transformation, say A, such that A of x equal to t into x. Then we define eigenvector. Eigenvector is nothing but a vector corresponding to this eigenvalue such that A of y equal to t into x. Find the eigenvalue and eigenvector of the transformation. It's very important. Find the eigenvalue and eigenvector for the transformation t equal to 1, 0, 0, minus 5, 2, 0, 2, 3, 7. We have tx equal to, yes. Then we have to find the characteristic equation. Characteristic equation is nothing but determinant t minus lambda I. T minus lambda I equal to 0. It is the characteristic equation. So what is the characteristic equation? Characteristic equation is lambda here t. 1 minus t, 0, 0. 1 minus t into I. Capital T minus capital T minus T into I. What happens? 1, 0, 0, minus 5, 2, 0, 2, 3, 7, minus T into I. That is T, 0, 0, 0 t 0, 0, 0 t. So we get first element is 1 minus t, then the remaining elements does not change, then say well, minus 5, 2 minus t and 0, 2, 3, 7 minus t. So characteristic equation is that determinant equal to 0. So we have, if t is a characteristic value, we can find the characteristic value by solving the characteristic equation. Characteristic equation is determinant of t, capital T minus small t into I. That is 1 minus t, 2 minus t, etc. That is the value. We can see that it is 1 minus t into the remaining elements are 0. So it is 1, 2 minus t into 7 minus t equal to 0. So we get three values for t. 1, t equal to 1, t equal to 2 and t equal to 7. So we have three characteristic vectors. First is, we can find the characteristic vector corresponding to t equal to 1. T equal to 1, that is the vector is t of x equal to lambda into x. That is t minus 1 of x equal to 0. T is 1, 0, 0, minus 5, 2, 0, then 2, 3, 7. So 1 minus t, that is 0, then 2 minus t, it is 2 minus 1, it is 1, 6. So it has only one characters, that is x equal to 0, y equal to 0 and z equal to 0 are the vectors for x equal to 1. Then we can find the t equal to 1. Then for t equal to 2 we can find 1 minus t, that is 1 minus 2. 1 minus 2 is minus 1. 2 minus 2, that is 0. And 7 minus 2, it is 5. So corresponding to this value we can also solve for this value. For t, and similarly we can solve for t equal to 7. Thus we can solve the characteristic values and characteristic vectors. Similarly, find the eigenvalues of, we can find the eigenvalues corresponding to the transformation r theta 1 to r theta. R theta 3 is cos theta minus sin theta 0, sin theta, cos theta 0, then 0, 0. Corresponding to this value, this matrix we can find determinant, so it is maybe A, determinant A minus t into I. We can find, solve for this equation, that is determinant cos theta minus t minus sin theta 0, sin theta, cos theta minus t, 0, 0, 0. So its determinant gives cos theta minus t the whole square plus sin square theta. Sin square theta plus cos theta minus t, the whole square equal to 0. It gives 0 only when these two terms are separately 0. Therefore, when sin theta equal to 0, theta equal to 0, when cos theta minus t equal to 0 means cos theta equal to t. So we have theta equal to 0, what point? So we have the t equal to cos theta, corresponding to this cos theta we can find characteristic vectors. Okay, thank you.